Okay. Yeah, Deepa the party. How are you?
Fine, ma'am. How are you, ma'am?
Yeah, I'm good. Okay, just give me 2 minutes. I'll go through your resume. So meanwhile, you can introduce yourself.
Okay, ma'am. I'm glad to introduce myself. Good afternoon, ma'am. I'm very much excited to introduce in the context of design verification rule. Myself, Deepa Dupati. I have come. I'm pursuing. ele- I'm pursuing Bachelor of Technologies in the stream of Electronic and Communication in Rajiv Gandhi University of Knowledge Technology, Srikakulam. I have completed my pre course in Rajiv Gandhi University and I have completed my secondary education in Jilla Parishad High School, Kallupalli. I am very much strong in foundation in digital electronic and Verilog and as well as system Verilog. I have done many projects like AES algorithm using Verilog and 4-port calculator using Verilog and smart car parking system on basis 3 and more projects and I have as well as I have done Arduino projects also line follower smart dustbin um, like that and I have completed in internship in NIT Varangal in the guidance of Raj, uh, Ravi Kumar sir and I have trained VLSI in semi designs. Thank you for giving this opportunity to introduce myself, ma'am.
Yeah. Okay, Deepa, that's good to hear. Just make your seat comfortable. Okay. Yeah, you did good projects like various projects will come with Can you explain AES algorithm project using Verilog HDL, how you implemented AES algorithm?
Yes, ma'am. I will explain you. AES means Advanced Encrypted Standard. We have chosen this project because how the word will be encrypted or decrypted. When it is a security code, we can't transfer without any security so that the word will be encrypted and transferred and when it has been received it will be decrypted and this algorithm have some steps. The first step is the word will be arranged in 4 cross 4 square matrix and second step is the 4 cross 4 matrix is state is converted as state matrix which is used for round keys and third step is n number of rounds which is depends on number of keys and fourth step is n minus 1 number of rounds which has four distinct points. I can clear that left shift and right shift and key lengths and adding. And for final step is adding an XOR operation for remaining rest of columns. This step is also called as added round method. Finally,
Okay,
these will be analysis completed. We can code in Verilog, ma'am.
okay. You are recent graduate, right? Which year passed out?
2024, ma'am.
2024. Okay. Okay. So how you rate yourself in Verilog and digital electronics?
Can you repeat it?
How you will rate your knowledge in digital electronics and Verilog?
Digital electronics is 5, ma'am, and Verilog
Okay.
is 4, ma'am.
Out of 5?
Digital electronic 5, ma'am.
Okay. Okay.
Verilog 4.
Okay. So, can you implement a XOR gate using 2 by 1 multiplexer?
Yes, ma'am.
XOR gate using 2 by 1 multiplexer. Just draw the diagram and you can share the screenshot in chat box.
Okay, ma'am. Give me 2 minutes.
Yeah, you can take your own time.
Ma'am, I have done. Ma'am, ma'am, I'm audible, ma'am.
Yes, sir, you are audible. Okay. Second question is, suppose there are two tri-state buffer. You know what is mean by tri-state buffer, right?
Yes, ma'am.
Can you tell me what are the terminals it have?
Input and output, ma'am.
Input, output, another third terminal.
Enable, ma'am.
enable. Okay. Suppose here it is like this. Okay. That means active low and active high. So what is the difference between these two tri-state buffer? What is the difference between these two tri-state buffers?
Active low buffer will gives the output as high,
Mhm.
means it performs in zero conditions, ma'am.
Okay.
Active high buffer performs in one's condition.
Okay. That's it.
Yes, ma'am.
Okay. Next question. So what is meant by propagation delay? What is the difference between contamination delay and propagation delay?
Propagation is a maximum time where the input value is changed for output, and contamination delay is the minimum time for input value changes until the output value remains same.
Okay. So here NOR gate delay is 40 nanosecond and this NOT gate is 10, AND gate is 30 and NAND gate is again 40, AND gate is 30, OR gate is 50. So what is the propagation delay of this circuit? Have you understood my question?
Yes, ma'am.
Okay.
Is around 110 nanoseconds, ma'am.
Okay. Okay. So next question, some X combinational logic circuit has given. Okay. So how can you calculate the frequency? Just I want to give the value of propagation delay as a 110 nanosecond, right? As you said. So propagation delay as a 110 and setup time is 20. and sorry, hold time is 20 and setup time is 40. So what is the frequency? What is the frequency?
Frequency is 1 by 170. That is similar to 0.005 like that, ma'am.
5 units?
It,
Okay. A 100 megahertz clock signal has given. 100 megahertz clock signal is there. So, how can you design a circuit using the D flip-flop to generate 50 megahertz or 25 megahertz clock signal? Derive a circuit using D flip-flop to generate 50 megahertz or 20 megahertz clock signal.
by using frequency division method, ma'am.
Okay. Can you draw that diagram?
Is timing diagram enough for you? I have to draw a
Yes.
circuit, ma'am.
Timing diagram is enough.
This is the timing diagram.
Okay. Okay. Here, can you see my screen?
Yes, ma'am.
Okay. So here two examples are given. Okay. So what is the block diagram of these two examples? After synthesizing, what is the schematic of these two examples?
Two individual D flip-flops, ma'am.
Okay. For both, it is same. Can you draw?
Both schematic is same, ma'am, but the functionality differs because first D flip flop is non-blocking
Mm-hmm.
of blocking, and second one is non-blocking, ma'am.
Okay. How many flip-flops will generate for first program, first snippet, and how many flip-flops will generate for second snippet?
2 flip flops, ma'am.
2 flip-flops for both. Is it same?
For both, it generates 4 flip flops, ma'am. For first one 2 and for second one 2.
Mm-hmm. Okay. You can check after this interview. And coming to the second example, what is the output of the second example? Schematic.
It will generate error because module input ports we have didn't declare Z, ma'am.
Okay. Will it generate error?
Yes, ma'am.
Can you check clearly?
Z equals to tilt E, ma'am.
You can draw the diagram and you can show.
Ma'am, this is
Okay. Then what about W or W and can you tell me what are the different data types in Verilog?
net and net data types and registers.
Okay. So what are the different net data types?
Wires, logics.
Mm-hmm. Is there any data type logic in Verilog?
Logic is not a data type, ma'am, but it is a data type in system Verilog.
Okay.
Only net data types and register data types, ma'am. These wire and wire or not belongs to
Hmm.
net data type.
Hmm. Okay. So what it will generate in place of WR and WEnd? Okay, fine. Do you
Does
want to
not
tell?
store any.
Hmm.
It does not store any output, ma'am.
Okay.
It will connect internally for the schematic.
Okay. Can you tell me what output of third example here? Third snippet. What is the output here? First of all, what is meant by fork join?
Fork join is nothing but a type of procedural assignment which gives the output in parallelly.
Okay.
Execution will be done in parallelly.
Okay.
Fork join consists of three different scenarios, ma'am. Fork
Okay.
join and fork join any and fork join none.
Just tell me what is the output of this snippet.
This will exit in total 35 nanoseconds, ma'am. Because fork join all every child thread is to be executed so that first 5 nanoseconds will be initialized and 10 exactly on 10 nanoseconds time will be displayed.
Okay.
The maximum time will be considered so that 35 nanoseconds.
First, which statement will be executed?
First at 5 nanoseconds will be executed. Initialization.
Okay. Yeah. Okay.
10 nanoseconds, ma'am.
Okay. Okay. Next question is, what is the difference between dollar display, dollar true, and dollar write? Also dollar monitor.
Dollar display is used for printing values, ma'am. When it is executed, it will print the values. And dollar stroke will it is used for time time stopping, and that means it will stop in the current time. And dollar monitor is used for overriding the previous value which is executed.
Okay. Will it override?
For the last call, it will be overridden.
Okay. What about dollar right?
Dollar right and dollar display or both are similar, but it does not terminate for new line. Dollar right,
Okay,
whereas dollar display will terminate for new line.
okay. Dollar right adds a new line and it doesn't. Okay. So what is the output here?
One x equals to 1, value of x equals to 1.
Okay. Okay. So you have mentioned the protocols also, YOT, I2C, AHB, APB, right?
Yes,
So
ma'am.
what is the difference between APB and AHB?
APB is advanced peripheral bus and AHB is advanced high performance bus, and APB is simpler than AHB because it is constructed for only simpler circuits, and this is low power consumption. AHB is high power consumption.
Okay. Can you draw the block diagram of YOT frame format?
Data format, ma'am.
Yes. What you did in YOT, have you implemented or verified?
Verified.
Okay. How did you verify baud rate generator in YOT? What baud rate you
Uh,
have taken?
Already default baud rates we have taken 2400.
Mhm. Okay. What is the formula to generate baud rate?
Can you repeat, ma'am?
What is the formula to generate the baud rate?
Because your formula is clock frequency by 16 into divided.
Mhm. Okay. Yeah, just draw the block frame format of YOT. Or else you can explain the frame format. Like what are the different bits?
Start bit,
Okay. Yeah. Can you explain FSM of ABB protocol?
not
Hello.
clear with that, ma'am.
Okay. You are not clear with APB. Okay. So you have mentioned project for port calculator. So can you explain about that? What is the functionality of four port calculator?
Four-port calculator has done operations like we have declared no operations and add, subtraction, shift left and shift rights.
Okay.
And also each port will consist four outstanding comments. For every comment, there will be four ports, ma'am.
Okay. We have implemented this project using Verilog or System Verilog.
We have used System Verilog, ma'am.
Okay. So how will rate in System Verilog?
We have given switches of 3 out of 5, ma'am.
Okay. So have you written any constraint like you are telling the commands, right? Like some value you are telling the some conditions, right? So have you written any constraint for that?
Constraints means we have given default like that.
Okay. So have you worked on coverage analysis?
Yes, ma'am.
Okay.
Theory
So
part we
how?
have done, ma'am, but
Mm-hmm.
in System Verilog, coding is not
Okay.
completely done.
Okay. So what is meant by coverage? What is the need of coverage in real time?
Because it helps in giving 100% of results, whether all the cases have been tested or not.
Okay. Okay. In system verilog, what is the difference between dynamic array and associative array?
Dynamic array is is resized, ma'am. It can be resized. And associative array is stored the value where the output where the value can be stored.
Okay. Can you explain the test bench architecture of system verilog? What are different components are there, and what is the importance of SVTB compared to the verilog?
Yes, ma'am. Uh, System Verilog consists of a driver, generator, monitor, and scoreboard.
Okay. You no need to wait for me. You just carry on.
And in the top module consists of environment, and environment consists generator, driver, monitor, and scoreboard.
Okay. What is the connection between those? How connections are established?
Generator is connected to driver. Here, generator is connected to driver, ma'am. And driver to monitor is connected with DUT. It the connection is interface. And monitor to scoreboard is connected as transaction.
Okay. Okay. What is the difference between blocking assignment and non-blocking assignment?
Blocking assignment represents with equality, and non-blocking assignment is represent as greater than equal. And blocking assessment executes in serially, non-blocking executes in concurrently, and regular and intra delays both are added in blocking assessment, and only intra delay is added in non-blocking assignment.
Okay. What is the difference between task and function?
Task allow always initial timing delays, but function does not allow any timing delays. And function is reusable. Both are reusable codes, and only the function will be called in functions, not in tasks.
You continue. Yeah.
Task will allow timing delay, and
Okay.
that's all, ma'am.
What are the advancements of task and function in system Verilog?
Task task executes in 0 time units, ma'am, where function is not.
Okay. So what is the difference between these two code snippets?
Last two codes, ma'am.
Yes.
Always when both the positive and negative clock and resets have been given, when compared to other, only the clock is declared.
Okay. So which one is a asynchronous reset and which one is a synchronous reset? What is the difference between these two?
Asynchronous reset does not allow clock, ma'am.
It doesn't allow clock?
Yes, ma'am.
Okay.
Asynchronous is a multiple thread operations, ma'am, and it runs in a parallel. Synchronous is only single,
Mhm.
only executes at a time.
Okay. So, yeah, one last question. So, what is the difference between full case and parallel case?
Ma'am, can you repeat, ma'am?
What is the difference between full case and parallel case?
It is logic cover for all the test cases, ma'am. Full case. Parallel case is either half of the cases will be covered, like mutually.
Okay. Okay. Okay, Deepa, I'm done. Do you have any questions for me?
No, ma'am. I think I have given the best.
Okay. Yeah, you need to improve more. Okay. In the example, asynchronous or synchronous reset. In few examples like the net data types, and here also in this example, how the registers will be generated for these two code snippet. You need to improve. Okay.
Okay, ma'am.
And APP protocol. Okay. Yeah.
Ma'am,
Thank you. Mm.
APP protocol is two cases, no, ma'am. And
No, it's
AHP
not
is
two cases. In final state mission, it have three states. Okay, ideal setup and access states. There are
okay, ma'am.
conditions also, like in first state, which should be high and which should be low. Like we have enable, right? Select signals and enable signals. So based on those, the data will be dependent, write and read address. So you need to go through those. And also the state, I didn't ask the state mission, like um waveforms also, right? What is the difference between wait state and without wait state? So you need to improve there. Okay.
Okay, ma'am.
Yeah.
I will improve for next one.
Okay, sure. Yeah. Okay, Deepa.
Thank you.
Thank you. Yeah, thank you.